Hey guys, so I'm not going to be able to have the Hacker Friday this Friday. It's my wife's birthday and I have plans, so I'm not going to be able to stay late. But a lot of people were asking me similar questions, so I thought I would just make a video of it so that way, you guys can still get that extra resource. So this week's lab, we're working with a struct. I'm just going to go ahead and write it out so I have it for reference. And inside that struct, we have our string. I believe it's called first name. Going off memory here, I don't have it in front of me. And then we have two integer values of age and CUID. And also we have a float for the GPA. Now in this lab, it's not type deft. And if you don't know what that means, that's fine. If you're interested, you can look it up. All it means is that we have to type in this keyword struct every time we want to reference this. So the reason that we're using structs in this lab is because in the coming weeks, you guys are going to make the switch to C++, and pretty much, unless if you're going the embedded systems route, you're going to deal with object-oriented programming. Yeah, it's just every modern language typically has what we call an object. In C, we don't have objects, but we have structs. So this is the closest thing we can get to in C to object-oriented programming. So it's a little bit different than the way if you're coming from just a straight C background and not transferring in from like a Java programming language or whatnot. It can seem a little confusing. So the purpose of this video is to hopefully help you guys make some connections and understand how object-oriented programming works. Real quick, let me make sure my microphone is on because that'd be really embarrassing if it wasn't. Perfect. Cool. All right, so in the programming assignment, we have void print students. And mind you, I don't have the code in front of me, so it might look a little different. But nonetheless, I'm just using this to drive a point home. Student, it's a pointer, S, and then we're also passing in another pointer. I think it's called num student, if I remember correctly. All right, so some people in my labs are seeing this portion, and we're freaking out about, what does that mean? What's going on underneath the hood? So this should be a hint, if you don't already have it, that you're going to need a pointer inside of your main. So you can literally take this same prototype and let's just say struct student. Imagine this is in main, and I'll fix that in a second. S. All right, and we'll just make it so it's more official. And then, since we're probably going to draw a lot, we'll just put that right here with our return 0. And I don't need a semicolon here. Cool. All right, so let's think about what we did last week. Last week, we had a 2D pointer, and we had a first name and a second name pointer. So if we were just to look at that first array, so we would have char f name, and then if you're using malloc, now if you're using calloc, I tell everybody in my labs, I am not familiar with malloc. I'm not familiar with calloc. I was taught malloc, so I'm not going to reference that in this video, but it works the same. So remember, when we're using malloc, the first thing we have to do is typecast. So I'm going to typecast for a pointer. And I'm going to use the keyword malloc. And I think last week, I believe I did 50. In this week's lab, you're only going to do 25. So you know what? Let's just put that on there for consistency's sake. 25 times the size of char. And this allocates our memory for first name. So now you guys have understood that what's happening really is that this pointer is now kind of working like an array, whereas every element is holding in a char. So I'm going to highlight these and make these different colors to drive a point home. So if we look at our red, we're telling it, hey, we want this our data type that we're using for this is a char pointer, aka a string. And then what we're going to use for the orange is just a character or char. So when you're looking at this, when you go to malloc for our struct, you can think of struct student almost the same way as you do this portion right here. Because remember, we have to tell the compiler what type of data we're going to allocate for our typecast. So that is literally what's going to go here. So the stuff that you've been practicing over the past 2 weeks, it still applies. But let me back up real quick and jump back into the array. So for first name, we understand that we can index this and iterate through it just like we would our normal array. So if I pass in Damien, now, we're going to have D-A-M-I-O-N and then a null character. And honestly, the same thing is going on over here. So once we allocate for our struct, I'm going to move down just a little bit. So in the lab write-up, it says to allocate for 10 spaces. So I doubt I'm going to get 10 here, but let's just pretend. So imagine that this is 10 indexes, right? So each individual box is its own reference or its own student. So this is going to hold 10 spots for student. And one of the analogies I used on my lab on Tuesday was, think of this like an apartment. This is an apartment building. And each index here from 0, 1, 2, 3, 4, and 5 is equal to a room. Now, or each floor here is equal to a room. So inside of, like, let's just say at index 4, the family that lives here is just a struct, student, and all the information that we have above here. So each individual element is its own instance of the structure. So that's really important when, we're going to be passing this around. You can access your entire element. So if I have this student S here, let's just say I want to make, after I malloced, and I'm going to leave this up to you to figure out how to malloc. Not that difficult, pretty much gave it to you. But let's assume that after I malloced and I went through and I have put in 2 students, but I want to change the GPA of student 3 or at index 3. Take what you have learned in the past 2 labs and you can still access, if I want to access this student 4, and I want to, now, so what this is saying is now we're looking at this student, and inside of here, we have an integer called age, right? And I'm just taking that from above. So if I want to access age, I can do s4.age, and now I can change that value type. So now I can make it 25, 253, whatever you want to access it to. So I hope that helps. The biggest point that this is trying to drive home is that even though you have an array of students, and you can look at this as an array, even though it's a pointer. Remember from pretty much what we've been studying, arrays and pointers are kind of the same thing, or can at least be used in the same manner. And at each element within our array of students, we have individual instances of the struct student. So when you're going through, you can use this notation to access it. And one of the purposes of having this second argument is so that we know which index we're going to access. So if I know that we have added 4 students, then I want to access that 4th element, hint, hint, wink, wink, that might be something to look into, is what is this value and how does it relate to S? Yeah, and I think that's, I guess we'll talk about one more thing and then I'll cut this short because I don't want this video to be too long. But So remember, each instance has a pointer in it. And I believe it's first name, but I'm just going to create something on the fly. So if each instance has a name in it, or it has a pointer in it, that should tell you, hey, if I have a pointer, let's just write this out as a rule. So if pointer, and this is just stating if a pointer exists. All right, let's just write this in English instead of getting pragmatic so it makes more sense. So if a pointer exists in my code, I'm going to put this in a different color to really drive this home. But if you see a pointer, that means we need to allocate memory, and that means you also need a free memory. So when you're freeing memory, not only do we have to free for this entire data structure, our struct, but we also need to iterate through and free for each pointer. And there's several different ways that you can do this, or there's several different ways that you can allocate for your pointer inside of here. I've seen some people, they have a for loop and they're going through each s at I and allocating this way. Some people have in the add a student function, they will allocate for that char array within that function. Either way is perfectly acceptable, but the biggest thing is before we can call strcp or string copy, this has to be allocated. Because what some people were seeing is that when they were trying to copy it over, nothing was happening. So they would print out their individual students in the display students function, yet nothing would populate. And if you're running into that issue, all that means is that your string array is not being allocated for. And I think that's just about everything I wanted to talk about today. Like I said, I didn't want to make this video too long, but I hope this at least helps you out. And, really try to spend a lot of time and get comfortable with working with, basically object-oriented programming. Because this is not going to go away. And whenever we get into C++, we'll start creating classes, and each class will have functions that it can call, and so on and so forth. But yeah, if you guys have any more questions, either shoot me an email, or I guess since this is on YouTube, leave a comment, and I'll try to get back to you. But yeah, guys, if you have any issues with it, let me know. Hope you guys have a great weekend.